Programming Throwdown, episode 76, Code Documentation. Take it away, Patrick.
I'm so excited to be doing another full episode again. Or I guess they're all full episodes, but a non-interview episode. Trying to get a bunch of topics off of the chest.
That's true. Yeah, we should... there's definitely, some interviews that are kind of in the pipeline. There's nothing immediate. But we definitely are really getting caught up on, a lot of our, focused episodes, I guess, so to speak, or non-interview episodes. And if people have suggestions, now's a good time to hit us up because, we probably won't have an interview next month either, so.
But also, I feel like people might groan a little and be like, code documentation? Really? You guys are scraping the bottom of the barrel? But Jason suggested this, and I thought about it. I actually think, I don't know. I'm kind of excited to talk. We'll see how it turns out. But
yeah, I mean, this is one of the most important things. Because other things, if we talk about specific languages, maybe you're never going to use that language ever. But this affects everybody. And,
hopefully.
And I think it affects everyone who's programming pretty profoundly, a lot more than you think. It's one of these sort of, you don't really imagine other people reading your code. Even just thinking about it, it's kind of weird. Just thinking about somebody else, just trying to figure out what your code is doing. Mm-hmm. But that happens all the time. And so even though we might not think about it, and so documentation, I feel like we have a lot of good things to say about it.
So the first thing I want to talk about is system design questions on an interview. And I'll do a little what that means and why, and then I'll let you go first, Jason. But to me, if you're doing an interview, and lots of people, listen, are either looking to get a job in computer programming or graduating college and looking to get a job, or even just, I actually think it's good to interview every so often just so you sort of get practice with it, even though I don't always do it as much as I should. And it is a lot of work, but it is one of those things I think being prepared to interview is always sort of good. And a system design question is instead of the expectation, at least at many tech companies, if you interview for a programming job, that you have to do coding on the whiteboard, the infamous whiteboard, or even just on a computer or something. System design is saying, hey, let's move this up a level from writing a program that you can do in 30, 45 minutes to talking about how you would design something. And still maybe in 30, 45 minutes. Sometimes some companies will do it a little bit longer for this question, but it's sort of a higher level question with more moving parts and often doesn't involve writing code.
Yep, totally makes sense. So we were talking about this a little bit before the show, but I do machine learning, as probably a lot of people know if you listened to our machine learning episodes. But we actually have a separate system design that's focused on machine learning that deals a lot more with statistics, like how do you sort of design it to be a little bit robust? How do you collect the right statistics? Things like that. And as Patrick said, you're not really expected to write a lot of code. You might whiteboard some diagrams and things like that. But it's really about how you tackle things at a high level. And what most of the time we're looking for, at least what I'm looking for, is, and it depends on the levels of experience too, but I'm looking for people who've kind of made kind of mistakes in the past and are already kind of preemptively, trying to design the system with those in mind. Or, people who start off trying to figure out the limitations and the scope of the problem and things like that. And sort of making sure they don't over-design, under-design, and things like that. And we'll talk about that in a little bit more detail. So it's probably pretty similar to a system design interview, just with a different topic. But yeah.
Yeah, so maybe an example for me, working at a company that has, or I guess any tech company that has a large internet presence, you would expect to get a question that has something to do with distributed systems. So an example of that might be, if you take an e-commerce site or whatever. I hate naming names because I don't actually, particularly want to. I don't know anything about the details, but if you just say it as an example, like Amazon or something. So Amazon has, people are familiar with kind of the UI. So it has a product page, and on a product page, you go there and it might want to say how many people bought this product in the last day. They don't do that, but maybe they want to. Maybe they want to add a feature.
Sure.
When you visit a web page for this particular kind of salt shaker. This salt shaker was sold 10,000 times yesterday. And they think that'll, give you, what did they call that? The social benefit of like seeing that other people are making this decision as well. And so they'll ask you, how do you design that? And so it's open-ended. There's lots of ways you can take this. So the first thing is to, make sure you kind of understand the kinds of things they're interested in hearing from you. If you're a web designer, maybe they're looking for, how you would figure out where on the page to put it or how to style it. If you are interviewing for an infrastructure job, you might start thinking about, okay, this is Amazon. They get a lot of people coming to the website. When it says yesterday, 10,000 people bought that, is that yesterday in the trailing 24 hours? And then how fresh does that need to be? Or is it in a bucketed, the last, sort of midnight to midnight day? And how do we compute that? How do you collect it? How would you produce it? Where would you store it? So Amazon has, I don't know how many products, millions of products, and all of them need this value. Is it something you would compute when a person loads up the web page? Or is it something that you would pre-compute, on sort of a rolling basis and store in a database somewhere? And if does that database need to be sharded? What would the query look like? Sorry, I'm actually not giving answers. I'm just giving more questions. But,
Sure.
These are the kind of directions you would start trying to take it in. And the person, depending on the interview, the person may give you more details or they may not. They may say, oh, yeah, actually what we have is, we have in a SQL database and we'd like you to write a SQL query to figure it out. Okay, well, that's not really, I guess, system design. So that's bad example. But they might say, oh, okay, yeah. So it turns out Amazon has 1 billion products. How would you compute this value for 1 billion products? And it should be computed instantaneously because we don't want to compute it for not popular products. But
yeah, exactly. That's a big part of it. Is if someone says, oh, I want to like compute it for every product. Well, you say, well, look, there's so much churn. Our inventory is, a gazillion products, a lot of which are maybe even discontinued or they're technically there, but no one looks at them. And that, we don't even have enough resources. And even if we did, it'd be a huge waste. And then you have to see like, okay, is the candidate going to adapt to that and say, oh, that's a good point. I didn't think about that. Let's keep some kind of cache. So, and have a write through cache, or is that the term? Anyways, have some kind of cache where, when you hit the product the first time of that day, you have to do some computation and maybe you put a filler number there or empty or something, but you're computing it. And so then when the next person goes, et cetera, et cetera. If someone just says, well, that's the thing I thought of and I'm sticking to it, even though it's wrong, that's probably not a good answer. So one thing in general is to be very adaptable, especially in the system design interview.
Yeah, I think that's right. I mean, I think it's okay to not know something, but as Jason pointed out, to just like stick to your guns. And if someone says, oh, I need it computed in the rolling 24-hour window, and I, computed to the last second or something, you can't be like, well, that seems dumb. I think we should just compute it each night at midnight. We'll run a giant batch job and compute it for everything. That would not be a good...
Yep.
I have seen people try to do that or try to force it into their comfort zone. But in reality, you really want to make sure you're answering the question the person's asking.
Yeah, that's the thing that's true in general, but especially for design interviews is the interviewer has a certain path a journey, if you will, that they want to take you on. And if you deviate from that journey, it can really impact your, ability to kind of pass the interview, right? So if someone says, oh, and I've done this before, I've been on the receiving end of this where someone really wanted me to use like a distributed processing system like MapReduce. And they said, well, you have to sort these numbers. And then I was like, oh, you can get a machine. Now they have machines with 2 terabytes of RAM or whatever it was at the time. I was like, so you could do it. You could just hold it on one machine. And he's like, what if it only had 1 gig of RAM? And I was like, okay, well, you could have files and then you could still do it on one machine. And what the reality is the person wanted me to go into distributed computation, right? At some point I figured it out, but try to read the cues from the interviewer, because they're going to want to sort of steer it in a certain direction where they're going to have a lot of follow-up questions and things like that.
But the one thing that I don't know, at least the background I came from, not working a lot with sort of databases and internet services, is the whole comfortableness with the aspects of database that aren't what I would have traditionally considered like writing SQL queries. Writing SQL queries are important, and I've espoused their value in everyday programming. But I think that also just understanding the kinds of trade-offs that at a big tech company, or I keep saying tech company, I guess a big cloud computer company or internet company, people who have a large web presence, there normally isn't only one kind of database. There are actually many kinds of databases. And this is something that I didn't realize and is important to a lot of distributed processing questions. So as Jason mentioned, like MapReduce is distributed computation. Well, if you're going to run distributed computation, inevitably you want to store it. And so how to have data that can be accessed by big MapReduce processes and stored from large MapReduce processes. Things for streaming data, things that need to be strongly consistent versus eventually consistent. What does eventually consistent even mean? How do you, like load balance queries? What parts of the system should be stateful versus stateless?
So I guess so if you want to prepare for one of these interviews, one big thing is look at what the company does, right? Because it's almost certainly going to, revolve around that. Think about like what are the biggest technical challenges at company X before you interview. Like if you're interviewing at, I'm just making stuff up, like companies up, but if you're interviewing at Google, to work on their search algorithm, then you're probably going to need to deal with handling a lot of data and looking for things in the data and things like that. If you interview at maybe like Tesla to design, a sensor on a car or something, it's going to be a very different system design. And so most people are going to ask questions that directly relate. I know when I do the ML design interviews, one of the questions is literally, here's a piece of our company. How would you start it over if we had to start over from scratch? And that's basically going to be the essence of almost any system. Now, there's definitely some like generic system design questions. But even then, they're going to revolve around whatever technology or whatever problems that company is solving.
Yeah, that's really good advice. And if I had to give, I don't know, unlike other things, that it's something you can just go to, a programming competition website and do some example problems. This one's a little different. I think it involves more reading, thinking. Like Jason pointed out, a great starting point is what the company does. But I think for me, the big thing that probably helps in a broad stroke fashion is understanding the kinds of databases currently used and what the differences are. And not like the difference between MySQL and Postgres. Like those are probably they're the same kind of database. They're just two implementations of a similar kind. But what's the difference between like Cassandra, which is eventually consistent, and MySQL? And why would you use one over the other? So that's like one area of research. Also, how data is indexed. So Jason mentioned like Google search. So understanding what a reverse index is and how would you do web crawling? When you do web crawling, how would you store the data in a way that's useful for doing search? How do you do string matching on, someone starts entering a word into Google search and it tries to guess what you're going to search? Right. And then how does it match that when you misspell something? Like, how would that work? How would you do that for very large data sets and do it really fast? Those kind of general topics, I think, cover, I don't know, I want to say cover everything or most, but I don't know of a great set of recommendations that would cover more.
Yeah, in general, almost every company has, I guess it depends on, I would say almost every company has some kind of front end. Like maybe you're plugging into some existing system, like you're writing a plugin for Salesforce. And so you're writing Salesforce, you're writing some schema that's going to be rendered in Salesforce, right? Or some other app. Maybe you're building your own app, mobile app. Maybe it's a website. Maybe it's all of those things, right? And so it's good to know, like, that company, what is their interface, their human interface, right? And then think about all the way on the other side, what sort of information do they need to store? And then how can you sort of connect those two pieces? Like, it's a good way to think about it is to sort of, and as Candles, if you're a top down or bottom up kind of thinking person, you can approach it from either end. But yeah, just think you have that's the two ends of the universe. And so you have to design kind of everything in between, right?
Yep.
So ML system design is pretty similar. I mean, we'll ask things like, for example, Amazon has the related products. So when you go to a product, it says, maybe customers also viewed this or related to this item. How would you sort of design that efficiently? Or if someone goes to the homepage and you get some recommendations quickly, but Amazon has a catalog of, a zillion items. So how can you choose the 3 most relevant items, in a quick fashion and things like that? So it's kind of similar. It just has a bit more of a statistics, like maybe like a stochastic bent to it, in the sense that, like, if you go to Google and you type cat, you definitely need to see a cat, right? And maybe, I don't know, the Wikipedia page for cat. I don't actually know what comes up first. But in this case, you could be wrong some portion of the time. If you don't recommend the best thing, Amazon's not going to crash and burn. But just on average, you want to be doing better and better. And so it's a little bit different for that reason, but there's a lot of similarities too.
Interestingly, cat gives me the stock ticker on Yahoo Finance for Caterpillar Company.
Nice.
But at the knowledge graph card on the right for cat animal.
Oh, okay. And then it has a link to Wikipedia or something.
Yes.
Yeah.
Second result is Wikipedia.
Oh, there you go. Cool. So on to news, unless you have anything else.
No, you were dying to know what now I'm going to do dog. Hang on. No, I'm just kidding.
Are they equal? Are Google employees, engineers, cat people or dog people? Let's find out.
Let's move on.
All right. So my first news story is kind of related. It's how to crush an interview. This is really, really, really good advice. If you ever plan on interviewing again, which hopefully is a lot of people, unless you're retired, you should definitely check out this video. The thing is, in our case, a lot of our interviews that we give or that we attend are very technical, right? People want we want to hire people and people want to hire us to do X, Y, Z. And it's very hard to know the person's competency over the phone. So, a lot of this advice, he even starts off, this gentleman starts off by saying, if you're at the on-site interview, they have your resume, they already want to hire you. This is how to make sure they like you. And that's, at least in tech, that's not true. There's a lot of people who we don't know if we want to hire them when they come on site. But still, a lot of the advice is like really, really relevant. Just to kind of like summarize it quickly, and I'll add my own flavor here a little bit because even though I watched it today, I was kind of busy. I was giving it full attention. But definitely be positive, be energetic, be kind of open to communication. Also, you mentioned have a few stories, which I thought was like profoundly useful. So, he said beforehand, come up with a few life stories that are relevant to whatever job you want. I mean, even if it's not, specific to a specific company, but let's say you want to be a banker. Well, maybe you ran, and I think the example he gives, you ran a lemonade stand and you collected money from people when you were a child and stuff like that. And maybe, and he said even have some negative things like maybe as part of that lemonade stand, you couldn't really manage the stand very well. And when people were working other than you, they didn't know what was going on and the stand collapsed or something, right? But he's like, kind of have that good narrative and, have kind of good stories that, revolve around why it's almost like you're kind of destined to be doing this type of job. And I'm kind of paraphrasing here. Definitely check out the video. That was just one of the tips. But yeah, I thought it was really, really interesting. It's stuff that I've always believed, but I couldn't really, kind of articulate it this well and kind of turned it into this sort of like a very concise, set of points. And yeah, I definitely would check it out if you're ever going to interview.
Getting off of interviewing from the first large portion.
Well, did you look up dog yet? What's dog?
No, I didn't.
Here, I'll do it right now.
Okay. Fascinating podcasting. Avoid else return early. This was circulating earlier today, actually, but it kicked off something in my mind, so I thought it was good to talk about now. This was an article, a blog about how, from a coding style, that a lot of people do this notion of only having one return function or one return statement at sort of the bottom of the function, and having big if-else statements for handling everything and then returning at the bottom. And they were saying, that they used to do this, but they basically have ditched it. And now what they do instead is, if they check something and there's a problem, they'll just return early. And if they go down somewhere else and it makes sense to return, they'll return in the middle. And then you just return wherever it makes sense instead of sort of having these awkward what they were sort of saying, these awkward if else. And the reading a lot of commentary on sort of Reddit and Hacker News about this, a lot of other people were saying, that they also had been taught this. And then I was realizing, I was taught this as well, like that you really want to only have a return statement at the bottom, that this leads to the most readable code, that the early return statements are problems. And I actually thought about it for a while and tried to figure out what was going on here. And there were some comments to this effect. And what I realized is that I think if you're doing a sort of language like C, and doing memory allocations and you return early, or if you're doing multi-threaded programming and you have a lock and you have many return statements, you need to make sure memory doesn't leak. You need to make sure your deallocations are done, your destructions are done, or that your locks are unlocked. And if you return early, auditing the code and saying that I know every code path frees its whatever resources it's acquired, that's tougher to do with multiple return statements. And so I think that it has more to do with that. But then realizing C++ with, RAII, resource acquisition is initialization, in other languages, having, sort of scoped locks and these kind of things make a lot of this sort of go away. That as you return, that the instances and the variables in this locking, you have more constructs which allow you to do these returns from various places safer. And I think that for some reason that it just sort of never caught up, that there's still this weird lingering paradigm being taught in school or whatever, I guess, that you should have this return statement at the bottom and that it's somehow more readable. When in reality, it was probably more readable given if you have to audit for this other stuff. But now that you don't have to, it doesn't. So there wasn't a lot of rebuttal saying,
I agree 100%.
Sorry.
I think it's like anytime you can avoid having, what's it called? Like having nested brackets. It's always a win, right?
Yeah. But I thinking just the other day though, like I was in a conundrum like this, like, oh man, I have an awkward set of returns early here. I really need to refactor this to get all the returns down to the bottom. And then thinking about it today, like, yeah, I'm actually not sure that I do find that code with the more nested brackets more readable. And in fact, sometimes it's difficult to know if you've kind of if-elsed your way out of something for a long time. Like tracing that logic through the code is not easier than just like doing it and returning it.
Yeah, I mean, my background is very different, right? Obviously, like I haven't done embedded things other than now I have this robot project, but and so like for my background, like, it's more like if you have a recurrence or some kind of recursive equation or any type of induction, you say like your base case, like, am I at my base case? Then just return. So in other words, if I'm doing some kind of Fibonacci sequence or something, it's like, okay, am I at the end of the sequence? Okay, just return 0. And then it's like, okay, I'm not at the base case, then do some recursion and return that. And so it's like, yeah, I mean, if you're doing any type of dynamic programming type stuff or recursive or a lot of AI stuff, it's like you're always thinking in that mode. where it's like you have some base case or you're just bailing early. Otherwise, you're going to do some other stuff. And so, yeah, when I see like that type of code, yeah, I mean, it looks so much better with, all the returns up front, clearing out all the cases that you're not interested in.
So, I mean, maybe there is some good counter arguments for having the nested if else. And in some cases, if you do need to audit the code in the way mentioned, and there's no other way of like having better constructs, that's probably reasonable. But yeah, I guess I'm currently feeling like maybe I should abandon the vestiges of like having a single return statement at the bottom. Like,
yeah, I mean,
I'm not sure what the reason to cling to it is.
Yeah, again, I don't know too much about low level, but like I feel like creating an object, it can't possibly use that much memory, like creating a empty class or something, right? And so you can almost always use scopes to do whatever you need to do there.
Well, I've got a story about work I was doing all day today about the minutia of optimization I was getting into that would make your skin crawl then.
Okay, probably. Oh, man. So, so my second story is... It's just a cute little infographic. It's called Idea Instructions, and basically someone took the visual style and the nonverbal style of IKEA, instructions. If you've ever built a chair, a table, or a bed, or anything out of IKEA, you know that there's, in the very first kind of page of the instructions, they kind of show you like these are all the parts, and this is what you want at the end. And they kind of walk you step by step, but every step is meant to just like show some kind of movement, but there's no, words at all, no labels. If anything, there might be like just very minute, like at the top, they might have two different types of screws. And so the very first page might say, like, this is screw, 900, and this is screw 901. And then later on, it might refer to those numbers. But other than that, there's almost no text. It's all just a bunch of pictures. And someone kind of took that sort of style and really treated it like an art style and explained a bunch of computer science algorithms, like quicksort and things like that. And it's pretty cute. It'd be a good thing to print out and put like, or get not laminated, but like just put it on your desk as like a cute thing, get it framed or something.
You do. I wouldn't say you could learn them this way, though. I did try to follow a couple. And for algorithms I knew, I was like, oh, okay, yeah, I see what it's doing here. But for algorithms I didn't, I was like, I'm not sure I followed this.
Yeah, no, even like, I'm looking at quicksort and like, yeah, I could kind of get what they're saying. But yeah, this has to be for people who already know what they're doing. And it's just a cute thing. Yeah, don't use this to learn anything.
So we're going to go for 2 YouTube videos. I think this is definitely a record for our link section.
Nice.
But this was sort of something that I'd seen a number of before, but this one was particularly good. It's something I've always been interested in cryptography. And that is, the name of the video is Dealing Cards with Cryptography with Ron Rivest of the RSA encryption algorithm. And it's on the Numberphile channel. If you've never watched this, most people probably have. It's a super popular channel. But Numberphile has got like math videos where mathematicians or other people explain stuff simply, and it's got its own style, and it's nice, easy watching. But this one has this famous cryptographer guy basically talking about how would you play a game of poker in the mail using the principles of cryptography. And so he points out like, well, if Jason and Patrick want to play poker, Patrick has the cards. Patrick can't just shuffle the cards, deal 5 for Jason and deal 5 for himself because there's too much incentive for him to cheat. Right. I would just give, oh yeah, Jason, all you got was 3 high. Terrible hand. Well, actually, that would actually be good. I don't think you can get 3 high and not have got pairs. I'm not a very good poker player. 7 high.
Yeah, right.
Okay.
Right.
All right. Okay, good. 7 high.
Yeah, if it's what is it? Texas Hold'em, right?
I think just like I think his example is just whatever 5 card. I'm not a poker person. I think just normal 5 card poker. But basically, like, how does Jason trust that I'm gonna, shuffle the cards fair, that we can compare fairly? And it turns out, yeah, he wouldn't be able to normally. But if you use some of the things that are used for cryptography, and he actually sort of takes cards, puts them in envelopes, and places actual physical locks on the envelopes. And it's just this really, like, I was watching it, and I don't know, maybe later I'll be like, why did I pick that for the show? But I was watching it was just hilarious because this is something I've always heard described, but I've never seen someone take actual physical locks, put them on envelopes, and sort of explain the algorithm.
That's awesome.
And of course, he points out, this is how computers do it. They do it really fast. They do it all the time. This is, in a way, kind of how public key cryptography is done. It's just done really fast and without real locks. But if you're curious about cryptography or just want to, I found it humorous. You can watch this Ron Rivest on Numberphile doing dealing cards with cryptography. I think he has a number. Now I'm trying to remember. I believe he's done other episodes on Numberphile as well. He's not the host, but he, I think, has made guest appearances on there several times, talking about other kinds of math. And he explains in the video as well one of the ways that public key cryptography is done, which is exponentiation modulo factor. Without going in super details, but if you don't know anything about that, then I would encourage you to check it out.
Cool. Yeah, I will definitely watch this video.
Right.
Yes, as this show's done.
Yeah, well, text me and tell me if I'm like should delete this portion of the show, and this is totally just that I had a weird quirk in finding it funny.
No, this sounds amazing. This sounds really, really fun.
So it's not a super long video, and it is not going to teach you to get a job in cryptography. So.
All right, it might teach you not to get a job in cryptography.
Book of the show.
Book of the show. My book of the show is Hillbilly Elegy, which is a really interesting book. It was a bestseller. I just happened to be crawling the bestseller list, and I thought this is something that is totally outside of, what I would usually read, and so I gave it a shot, and I thought it was great. It's basically it's one of these things where like the environment. It's a nonfiction book. It's about a real family. It's anecdotal, and yeah, the environment kind of is the book. So without really spoiling anything, let's just say like basically, okay, after there's this big industrial age. There was a lot of manufacturing jobs, right? People working in like steel plants, things like that. A lot of those jobs kind of went away. And this is somebody who I think he grew up. So I think this person is probably in their 40s, I want to say. And so they're coming kind of on the tail end of that. Or maybe they're younger than that. But anyways, so they're coming on the tail end of when a lot of those manufacturing jobs really went away. And it basically decimated this town. And it talks a lot about, a variety of these towns in Appalachia, which is people aren't from the U.S. or people don't know. It's like Kentucky, kind of Tennessee, Pennsylvania area. And just about kind of how they got decimated. Nobody really knows about them. They have a lot of pride as a people, but they're also like kind of suffering like immensely. And it really kind of talks about a lot of specific things. Like I've driven through, Kentucky and Tennessee and Pennsylvania, but I've never actually stopped in any of those states. And so I know very little about their culture. And so this was like a really interesting insight into that culture. And it really talks a lot about specifically like why some people in that area or maybe in the U.S. and broadly are struggling. And there's a lot of reasons why people are struggling. But if you were to ask me for, let's say, even 10 of them, I probably wouldn't have even give one from this book because I didn't really think about things in this way. So it really is interesting. I mean, it's not an uplifting book, although it ends on a high note with some people really sort of making the best out of their situation. But it's a pretty heart-wrenching book, but super, super interesting. A great story. It really kept me engaged. It's, I kind of tend to, one day I'll start reading a book or continue reading a book. Another day I'll do something else. This book, I just blitzed through it because it really captivated me. And I think part of it was that it was so different from what I usually read. So yeah, I would highly recommend it. It's a bestseller, so it's really high quality. And yeah, I think it's a fantastic book. I read it on Audible.
Nice. I'm listening to Oathbringer, which is the third book in the Stormlight Archives trilogy by Brandon Sanderson. I think I've had the other two books on here before. I actually have read a couple other books, but I didn't really care for them. And I dislike giving like mediocre. I have done it a couple times, but I'd rather talk about something I'm really enjoying,
Yeah,
even if I haven't finished
choice,
it.
Right?
Yeah. And so this one I'm nearly done with. So one of the things I want to point out is, first of all, this is the third book in a trilogy. And I just looked it up because I'm listening to it. It's 55 hours. This book, the third book. The others are almost as big. And so this is a massive amount of like commitment to get through all of these. And I was reading, so I was curious. It says the hardcover is about 1,200 pages long. If that helps you think about like how big, 1,248. And I was thinking another book I did read in actual book form was Anathem, that I thought was like a very big book by Neil Stevenson. And that one's only 937 pages. So I'm not saying that like it's amazing just because it's really big, but it's taking me, I was shocked. It's actually taking me kind of a long time to get through it. Are
books on tape or Audible books faster or slower than reading? I mean, I know it depends on the person, but like, does an average person, or you, for example, do you read?
I read much faster than the Audible narration.
Oh, okay. Even if it's because there's reading like skimming through something.
No. Like just my normal reading speed is quite a bit faster.
I never really thought about it until now.
I mean, I've never like raced.
Sure.
But I'm pretty sure even like, I'm sure I could read slower if I wanted, but like even just reading at like an enjoyable pace for me, I read much faster. The thing for me though is finding time. I guess I'm just too distracted, but like finding time to sit down and actually read a book is tough. And so I tend to not get it in as long of periods, versus it can take me 45 minutes or more to get home nearly every day. And so that is a time when I can sit there and do my, get quality time with a book.
Yeah, makes sense.
And so for me, even if I could read faster, so like this is 55 hours, it might only take you, I don't know, whatever. I don't know what the ratio would be because it depends on your speed.
Maybe let's say 20 hours.
Yeah, 20 or 30 hours. But for me, finding 20 or 30 hours to read this is just like I don't currently have it scheduled in, and so. But I enjoy the content a lot. And so,
makes sense.
But Oathbringer, I'm like 3 hours left or something. So
wow,
I'm down at the finish line. But I don't know that it's going to have an amazing ending or not quite at the end yet. But I've really enjoyed it so far.
So you've talked to me about or talked to us in the past about world building versus kind of building story and things like that. Where does this fall in that sort of axis?
So, I mean, if you have that much time pages to go over something. So this is interesting. I think this definitely qualifies as world building. So it's very much about people and about stories, but also about a lot of you learn a lot about the world these people are living in. And one of the books I read that was a collection of short stories. This is not the one I was saying I didn't like, although I'm not a big fan of short stories. I don't feel I can get into them. But a lot of Brandon Sanderson's books take place in a sort of meta universe called the Cosmere. Anyways, this is like super detailed. I guess it doesn't matter. But he has a bunch of books that sort of feel like you can just read them in isolation, and they are in isolation. Except that it turns out they're all really in a bigger universe. And there are like common traits about the bigger universe. And so there are sometimes Easter eggs between the books, if you read between the books. And this collection of short stories has a lot more detail about sort of the behind the scenes inside baseball of, kind of that thing. And so I think not only is he doing world building on like a per series basis, but he's also collectively building all of the worlds together into one universe.
That makes sense. That sounds similar to like Terry Pratchett books, right? Where there's a I guess an engine, for lack of a better word, with a set of rules and an environment there. and all the books take place within the same engine. And so there are certain things that happen that seem kind of just serendipitous, but over time you start to understand how the engine works. And so then when you see that thing again, you're like, oh, even if it's in a different book, you kind of know what's really going on. And someone who that's their first book isn't getting it yet. So like one of the examples of this is the number 8. The number 8 in Terry Pratchett books is you can't say it if you're a wizard. So you have to do 7 plus 1 is 2 to the third or something like that. If you say 7 plus 1 is 8, then you get, I don't know, struck down. I can't remember exactly what it is. And so there are just times where that comes up. And eventually you read the handful of times in the series of books where that's relevant. But then there's still, other times where it happens and it's just kind of part of another story. And it just kind of happens, and if you know that, you're like, oh wow, that's so cool. Like, it's funny that just happened. That guy got obliterated by a lightning bolt because he said the number 8. But if it doesn't happen, it just seems like just some serendipitous thing. Like, what, the lightning bolt struck that guy down? Okay, let's go on to the next thing.
Yeah, so I to conclude, I mean, Oathbringer is a really good book. I'm going to recommend it, even though I'm not finished with it yet. But a little hard to give. I haven't shared anything actually about the book yet. But it's hard to when it's the third book in a series. So go check it out on, I guess, Amazon or Goodreads or wherever, and sort of read if you're interested in the summary or the back of the book. But you'd have to go to a bookstore to find the back of the book. So not going to recommend that.
Right. And you could read that on Audible. And if you're not an Audible member yet and you want to join, use our link that helps us out. You go to audibletrial.com/programming throwdown, all one word. And if you are an Audible member or you want to support us in any other way, you can go to our Patreon. Just an update on the Patreon. So I think we're set on the design. I'm going to print out tonight. My printer actually broke.
No.
But yeah, I got a new printer yesterday, and tonight I'm going to print out the all the thank you letters we're going to write. We're going to stuff those in some envelopes along with the emblem, and we're going to start mailing those out. Hopefully, in a couple weeks.
Yeah, I also had laser cutter issues, so I am lagging behind in getting all of the logos cut. So,
but yeah, it's going to happen.
It will happen before the end of the year.
Yeah. And, every Christmas we're going to do this. Hopefully, we'll get it more streamed. Well, we're not going to do this where half our hardware breaks. But, every Christmas we're going to do this giveaway. I have had my printer break, which sucked. But overall, it's been really fun. Just, part of it is just looking up where people live. Like, because, we need your address to mail you out the emblem. Just seeing that we have people all over the world who support the show is really exciting. And being able to, make something and something kind of real and physical and send it off to the people who are listening is really cool. And so we hope you all keep subscribing. Definitely tell us, you can use the Patreon chat, which I follow, I monitor or whatever. Tell us what you think once you get the emblem. If you get it broken or something, definitely let us know. But in general, we appreciate so much your support. Also, if you're in Russia, where our podcast is banned, not because of our podcast specifically, but just our hosting provider is banned. If you're Russian, you can access the Patreon RSS, which is super fast and works in Russia. So
nice. Tool of the show.
My tool of the show, it's actually 2, but they both do the same thing. iFunny and 9gag. So these are apps. One is iFunny, kind of like iPad, like the letter I, funny. But it works on Android and desktop and everything. The other one is 9, the number 9, gag, so 9GAG. Both of these are just basically a feed of funny things. And you can kind of tailor it. It also kind of knows, based on your upvotes, it kind of sorts it accordingly. You can also look up certain things if there's a certain topic you want to follow. But it's just a list of really funny things. It's usually memes, usually like a picture with some text. It could be a video with a caption. But I'm one of these people, I really believe a lot in this idea that, especially when it comes to emotions, that we're all like much simpler than we would like to believe, right? And so if you just see something silly and laugh every day, I think it actually will have a profound effect on your mood. And even though it sounds like such a forced thing, and I wouldn't go into it saying like, oh, I need my funny medicine today or anything like that, right? But just in general, it's good to have like systems in place that, that improve your life. And for me, this is one of these things. Like I have these apps, they send a notification like roughly every day. And so I can kind of, tap notification, it logs me in, and I get to see some really funny stuff. And if I see something really funny, I'll share it. So occasionally Patrick and other people get kind of random memes. They're kind of like, where did this come from? And there's no context at all. It's just something funny I saw in one of these apps. And I think it's one of these things that really kind of, it'll let you sort of bond with other people too. Like, especially like you might not have a reason to talk to Aunt Sue, but you can always send Aunt Sue that video of that cat, getting stuck to a ceiling fan or something like that.
No, I'm going to have to scroll through all of the... No, I'm just kidding. So, speaking of things that definitely don't waste your time...
yeah, right.
Jason informed me I'm behind and I'm not hip like all the cool kids. But I started playing PUBG because it came to mobile, iOS and Android. And I've been playing on a tablet. So not only did Jason tell me that I was behind the times and that he's been playing this for like literally months, but then he proceeded to tell me that the reason I am so good is because it was actually full of terrible bots and that I wasn't actually beating people. I was just beating crappy bots. So I was really stoked and now I'm just really sad. So I need to stop the podcast and go back to playing.
You got up to where you were playing people, right?
I believe so. At least I'm getting crappier. One of the two.
PUBG is PlayerUnknown Battlegrounds, and it came out for desktop initially. And a coworker, someone on my team, actually said, "Hey, you should buy this game, and we'll play together." And I said, "Okay." So we played it, and it's just really hard. And also, I'm just generally not very good at games where you have to kind of be accurate. Like I don't have a lot of dexterity, and so. I think I looked at my ranking. Now, granted, I don't play that much. I play maybe 2 hours a week or something. But my ranking is, like, I'm in the 70th percentile. And I probably 29% of accounts are inactive or something. So I'm not at all good at this game.
But just for people who've never played, it's actually really cool. I was explaining it to my wife. And I mean, I'm late to the game. I had heard about it before, but I've never played it much. Or I never played it, never watched a video of it. But roughly, the idea is you and 99 other people get dropped onto an island. And it's sort of kind of like a mix of various themes you've seen before, Hunger Games, some different kinds of movies. But your goal is to survive and be the last person surviving. It doesn't take terribly long. I don't know if the computer one is the same, but on tablet, it typically takes like 25, 30 minutes maybe.
Yep, that's about the same.
And so what happens is after just a couple minutes of being on the island, there's going to start being a circle, and you have to be inside the circle or this like energy field will come crush you and you die. So basically, there's an ever-closing circle that you need to stay inside of that's compressing anyone who's staying alive down into a smaller and smaller area, thereby, in theory, if there was lots of people, the density would go up and they'd fight each other. But you can also collect, but you start off with nothing, and you need to collect armor and weapons and ammunition and health packs, and you're running around scrambling trying to find it. And if you come across someone, then you'll like fight or run away or, whatever.
And running is actually not a bad idea, as opposed to other games where, if you're playing Unreal Tournament or Quake or one of these games, you just run around shooting everything. But this game, is a lot about sound. So if you shoot, everyone's going to know where you are. And people who are really good at the game might say, oh, if I hunt that person down, I can take his equipment. So not, just letting someone run away is actually not a bad strategy.
Right. So, running away, knowing if you're outgunned, knowing if you are going to draw someone's attention. There are some vehicles. You can drive around the vehicles. You can hit people with your vehicles. Sort of a free-for-all. I've been enjoying it. I don't know how long I'll stick with it because, it's one of those things like for me, it was kind of fun like goofing around and like, doing reasonably well at. But I'm not sure I'll invest the time to sort of get amazing at it. There seems to be lots of subtleties in exactly what weapons loadouts you tune for and how accurate you are. And it's also quite a bit stressful.
How does the shooting work on mobile?
I'm pretty sure it's similar. It's just you use on-screen controls or whatever.
Well, because like, for example, when you have the sniper rifle, you have to be extremely precise with the mouse to hit somebody.
I mean, it has some amount of auto aiming on, but I don't know to what extent. So, you don't play between a computer and a mobile device. So they're actually two different implementations of the game.
Oh, interesting.
As far as I understand.
That makes sense, right?
Yeah.
You'd be at a huge disadvantage if you're on your phone and someone
or
else
vice
has a
versa.
mouse.
Or if they have too good of auto aim, then you'd be at a huge advantage.
Oh, right. That's true. Yeah.
Yeah. So.
I'll have to try the mobile out. I actually downloaded it, but I haven't played the mobile version yet.
So everyone probably already knows it. I recommend YouTube channels that have like 2 million subscribers and currently most popular iOS games. Let's move on.
Yeah, you're such a rebel. Way to go against the grain.
Although you told me you literally pitched a book as it's good. It was on the bestseller list.
Yeah, we're just shilling. This whole episode is just an hour of us
We've
shilling.
jumped the shark.
The most popular. I mean, PUBG. Bestseller list, documentation. I mean, what's more popular than these things?
Yeah. And now we're going to talk about documentation.
The most popular thing ever. Documentation. So, the first thing is, and this is really true of anything, is why document? And maybe we should start every language with, why does this language exist? We kind of do. But, why document, right? I mean, it slows you down. If it's not done right, you have to keep it up to date. I've actually seen some pretty funny code. We have this thing called Clown Town, and it's just a group at work where people post just like bad code. And it's usually just things that have like gone south over time, like rotted in a sense. And there was one that someone posted and it said, the comment said, return 1, but I don't know why. And then the next line was return 0. It was like, so, that can happen. And so, the reason why, we want to document, and someone explained this to me at work, it's about 5 years ago, and it was so profound. It's just one of these things you don't think about is, if you're at a company, you're almost certainly going to have some type of code review, which means like you're going to read your code because you don't want to review just, you don't want to embarrass yourself, right? So you're going to go through it, and then the reviewer is going to go through it. And even if you only have one reviewer and no one ever looks at it again, that's already twice as many people. If you count your second pass, it's already twice as many people that have read it than written it, right? And chances are it's going to be way more than that, right? You might send the code review to 2 people. There might be other people on your team who look at it. Right. Also, you might come back, 5 years later. This has happened where you come back 5 years later and look at something you've written, and you're basically a different person at that point because you have zero context. You're probably using this code for a different reason, and so that's yet another context that has to get filled in, right? The other part of it is you want to document to sort of let people know the intent of your code and also the span, right? So, I mean, we talked about the design interview at the beginning of the show, right? Maybe you have a function that sorts less than 100 numbers super quickly. Like it runs on some, assembly code or something. And it's just insanely fast, but only sorts 100 numbers. Well, like you need to let people know, right? And there are actually like, what's the term for this? There are actually like programming language constructs where in the, in the input you specify like what's expected to come in and what's expected to go out of this function. I'm totally drawing a blank on the term for that. But in general, most languages aren't like that. Like most languages, you just say this takes an int. You don't say this takes an int of this to this range, right? I think it's like contract-based programming or something. Yeah. But we're not writing like that. Almost none of us. And so the documentation is really what's going to let the person know, like, this is the kind of input I expect. This is the kind of output I'm going to produce, right?
Even just simple things like if you're in a language that has null pointers, that like, can this be null?
Yeah, exactly.
Yeah, as I expected. So, I mean, the first kind of comments to talk about is sort of generic across every kind of language, I guess. But most, at least as far as I know, every language has is composed of source files. And there's kind of... And I've had this debate back and forth with people over time. Like, do you document large sort of descriptive comments at the top of a file? Or do you mostly focus on commenting, sort of at the line or at the call site or at the function signature or wherever the applicable place is? Do you do both? I mean, ideally, you would just document everything all the time. But, it is tough sometimes because, like Jason was pointing out, you want to document this so when you lose the context, you can come back to it. But it's also hard because I think sometimes people comment the wrong things. Like people comment the obvious things.
Right.
And not the subtle things. But that's really tricky because when you're in it and the context is fresh in your head, the things you think you might need to comment are stuff that is probably easy to figure out later. And the stuff that you chose for some subtle reason, you may not think to put a comment on. But, generally, I think it is good at, especially for large pieces of functionality, to have a bunch of comments up at the top that sort of says what the point of the file is, what the direction you're going in, maybe some use cases.
And that's going to force you to organize your file system. It's going to force you to organize your source files in some meaningful way.
Yeah. I mean, I'm a big fan of like documentation at all levels, if that makes sense. Like your organization of your code should be somewhat documentation, like what files are in what folders, for instance. To me, or in what modules, is like a form of documentation. Like have a logical layout so that if someone's like, I wonder where this thing lives, they have a reasonable chance of finding it on the first try. I've been in code bases before where things just are all over the place. They don't make sense, or just one gigantic folder. I don't care for that as much because I feel like it's documentation in depth. That's what I'm going to say. Yes.
Yeah. I think too, another part of it is it's a living system in a sense because there's just constantly people modifying it. And usually when you see, for example, as Patrick mentioned, a directory with 200, source files in it, like nobody really set out to say, I want this to be the one directory to rule them all. What happened is someone started with one file and then 2 files and then 10 files. And nobody really stepped in and said, okay, we need to, I'm going to take a month to sort of break this up into 10 different directories or something. And so, it's going to require like constant effort. And that gets back to the downside of commenting, which is, you have to maintain that. But the upsides are well worth it.
Yeah, I mean, I don't think anyone's going to disagree some documentation is good, but finding the balance can be tricky because I find sometimes you get really long comments that you end up skipping because it's just like, oh man, this person, like this. Yes, I know you're just looping over all the things in the list. Yeah, I got it.
Yeah, exactly. Yep. I think there's also ways to sort of self-document. I think, as Patrick mentioned, you can do the, document at the top of the file. You could do documents in the functions. You can documents within the code, things like that. And the nice thing about those is and we'll talk about these later, is there's something called generators that will kind of basically create a manual of your source code automatically. But in addition to doing that, something else that's basically free and it'll save you from having errors in the future. So it's kind of a no-brainer is to basically write self-documenting code. And so one example of this, and we'll kind of trade off different examples, is, and they always talk about one of the biggest challenges in software engineering is naming things, right? And so it's kind of like a tongue-in-cheek thing to say, but there's a lot of truth to that. I think, picking variable names and function names is super, super important. I've noticed over time, especially now that I've gotten good with, Emacs key bindings in whatever editor I'm using, I have pretty long variable names. And I find that that really helps a lot. So for example, the other day I had something where it was a data structure that was, a list of models, and then each model was a list of examples, and then each example was had a list of features. And so I had a variable called, top, or I think it was like, root or something like that. And then I was interested in the first model, so I created another variable that was called, examples _for _model _0. And then it was equal root, index 0. This is like a huge variable name, but it tells someone exactly, what that data is representing. And if you're using something like JavaScript, with ES6 or C++ or something where you could do const, that's even better, right? Because now that variable is only ever going to represent that thing and people know it. In my case, I'm doing Python, so I don't really have const. But, and it kind of, that kind of style and doing that with functions as well really helps. And it could probably save you from writing a line of documentation there.
I mean, I think anytime you have variables and are able to use them, like Jason was pointing out, rather than just indexing in. Now, obviously, you could take it to an extreme, but providing extra context for something, breaking up stuff into different functions. Oh, that's a lot of stuff. Breaking up things into different functions and saying, hey, I'm going to put a function here, not because I need to, but because it makes it cleaner to read. Anytime you can limit the number of variables, any piece of code you have to sort of think about to be able to execute, that's also going to be an advantage. Although we just said to make new variables. But I mean, the keeping variables that are related around are good, but if you have code that just sort of becomes really long and there's lots and lots of variables in play, that also becomes difficult to read.
Yeah, definitely. I think one thing I do when I'm doing C++ coding, and tell me if you do this, Patrick, is I tend to put a lot of extra braces. Like the braces aren't connected to an if or a for or anything like that, but it's like I have a set of, and maybe these are things that really should be functions. But, I have some variable that I know is just going to live for a few lines of this function. So I just put braces to let people know, like, look, this variable dies right away. And so, don't expect it to be around the rest of the function. And that kind of helps people modularize it. I feel like there's a trade-off. Like you could just have a lot of functions and let the function, define all the scope and all of that. But at some point, that actually can get kind of hard to read because you end up with a lot of functions kind of scattered all over the place. And you have to be careful, like, how you sort of order them and things like that. So it's pretty readable. So I've found that particularly like for small things, let's say like less than 10 lines, instead of making a function for that, I'll just wrap the variables in braces so that, C++ kind of destroys it, which that's not really that useful per se, but it's really just that people know that this variable has a very small, context.
I mean, I have seen that before. I don't tend to do the exact pattern you're saying. I mean, there are certain cases with like standard locks, or if I have an expensive allocation where I need to do exactly what you're saying. I think people could use I don't remember what that's called, the curly braces without a if or for loop or whatever, just the empty sections or the sections.
I think it's just called a scope, but I don't know.
Okay, yeah. So like using scopes, probably could use it to better effect. But I mean, I think you also don't want to go overboard.
Yeah.
Like it isn't a standard thing. And, so yeah. But I mean, I think all this stuff is to say that you try to be careful in what you name things and use the features of the language to your advantage and trying to help it make it descriptive. But we've also pointed out that types are a form of documentation, despite Jason also said that he was working in Python. But
actually, hey, Python, I don't know if you know this, but we use Python 3 and we use types on everything.
Oh, everything.
Yeah,
Dude,
so Python 3 has a typing. You can import typing and then say like, actually you do from typing import, dict and list and all those types, right? And then we actually have a type checker. I think it uses MyPy, but
nice.
But yeah, I mean, there's not like what's the word? Like a mandate or something. It's like, oh, you didn't put a type here, you're fired. But it's like, if someone writes a whole file, for example, with no types, then they'll probably get some feedback like, hey, you should put types here.
Nice. That's good.
Yeah,
because
yeah, the types are super, super important. Without types, it's just a night. Actually, Patrick and I, it was the time we worked at the same company, and we wrote a bunch of Python without types, and that was pretty rough.
Jason wrote a bunch. No, I'm just kidding.
You're right.
I know a lot of people really like stuff without types. We can get into that. Let's save this for a different discussion. Let's keep going.
Sure.
So generators. So the idea of a generator is writing comments or specially tagged comments in your code that then gets exported to a web page or a PDF or a different form that sort of summarizes your code without containing your code itself.
Yep. And you've probably seen this if you've ever seen, like, you can tell because it kind of, not to start off by disparaging it, but it kind of looks goofy because these generators, they have to design the way they look based on anything that could come out of your code, right? And so if you've seen this weird sort of 4-panel type website where you have all the Java, namespaces in the top left panel, the classes in the bottom left, and then I guess it's 3-panel, and then on the right you have whatever class you're looking at the moment. And you'll know it when you see it. It's like they all kind of look the same. Very few people actually change a default template or the default theme. But yeah, that's something that was auto-generated. And so those people don't have to create that website or anything. They just run one of these generators and a website comes out. They just have to put it on a serving platform somewhere.
So I'm going to start this off by saying I actually dislike code generators as a whole. I tend to not use them. And
like you talk about like the document generators or just code generators in general?
Oh, no, document generators.
Oh, okay, got it.
Yeah. Like Java docs, if I'm writing Java, I dislike going and reading Java docs. I don't find them valuable. We have some pieces of code that have Doxygen comments on them. I never generate the Doxygen and go look at it. I don't know.
You don't think other people do? Like other teams or whatever?
I'm a skeptic. I'm waiting to be convinced. I think they have their place. And I think if nothing else, I think they're really useful for sort of enforcing a style to comments. Like you should comment on what your return type is. You should comment, that each public function, for example, should have some comment on it that says what it does. But I'm not the problem is a lot of times when you try to make them very rich, they actually become less readable in the code. And so I feel people end up in this dichotomy of either making the generated docs good and the code bad, or the readableness in the code better and the docs bad.
That's a really interesting point. Like, I'll give you a specific example where I agree with you on that is the parameters. So if you want to do, if you want to support Sphinx in Python, which is one of the code generators in Python, if you put like at param, whatever the parameter name is. So if you have a parameter name like number of places, you do at number of places, colon, or I think it's at param space number of places space, and then a description of what that parameter is. And if you do that, it looks really nice. The output of that, like after you run Sphinx and you look at the web page is generated, it's really nice, and you can hover over the parameter and it reads it to you in like a tooltip, right? But the actual documentation looks ugly. It gives these @ signs randomly, and plus people start explaining parameters that don't need to be explained.
Yes.
It's like, I know what that parameter means,
Yeah, that's the thing for me is like, not only does like the documentation become sort of a little difficult, and especially when people start using hyperlinks and stuff, and I don't
right.
like, it just becomes really messy. So having a hyperlink in your code is okay, but then having it flagged out and tagged properly so that it gets, looks good in the documentation just becomes very cumbersome. But as Jason pointed out, a lot of times, which is true of documentation just as a whole topic, is like understanding some things don't always need to be documented. And so something like, I'm trying to think of a good example. It's like one of those things.
Well, here's an example. Let's say you have an array of, model, an array called models, and then you have a variable called number of models because you're doing this in C++.
Yeah, sure.
Yeah.
And you really write a comment. Number of models is number of models.
Yeah. Yeah, exactly. Yeah.
Or a function called getIndex, and it takes in a variable called I, and you say I is the index of which to get yeah. Ugh.
Yeah. And yeah, to Patrick's point, like, when you use a generator, it really compels you to have to explain things that probably don't matter. And, what that means is people will get a little bit more deaf to your comments. Because if half the comments don't matter, they're going to pay less attention to the other half.
I guess I also have this worry that there's a sort of a amount of time people will spend documenting, and I want them to spend it on the stuff that matters most. And if they're spending it on, cleaning up the formatting and spacing of every one of their parameter names that don't matter, they're not spending it in like restructuring the code in just a more readable, maintainable way.
Yeah. On the flip side, though, like if you look at really core libraries, they make tremendous use of this. And this is like, library, like TensorFlow, or for example, like TensorFlow, there's so many people using it. They're in a sense taking a risk because, they're using TensorFlow instead of building their own thing. And if it turns out they need to extend TensorFlow in some way, they're really counting on, there's like a social contract there. And if you don't have the generator, it's kind of hard for people to get started, just diving in through the code. So I don't really have, this is going to be a weird show in the sense that we don't really have a silver bullet. Maybe this is an opportunity for someone to like invent something totally novel. But, I agree with Patrick that the generators kind of cause people to write very odd comments and not very well structured comments. On the flip side, if people use the generators but write only the important comments, then the generated output doesn't look very good.
It's not complete, yeah.
Yeah, because what the generator will do is it will print all of your functions, but then the majority of your functions will look very bare and it'll look very bizarre. In general, that's a problem with generators where, you might have, like, let's say you have a helper function, sort array or something like that, and it's just helping your class do something. Maybe it's even private. The generators, now there are rules, or maybe they won't, generate docs on private functions, things like that, but you're still going to encounter cases where things are basically going to show up in the documentation that don't matter. Like a lot of the functions probably don't matter to 99% of your audience. And so all of that, I think, maybe generators, but with a lot of hand-holding could be the way to go.
But you brought up a really good point though a minute ago about saying like part of this is and you're sort of elaborating on it now, like part of this is how many people are going to be using your code. If you're writing some like deep internal something that isn't really going to be shared by a lot of people, then the documentation is important, but the kind of like put it out to a website maybe less so. But something like TensorFlow or something that's going to be a common utility, then it's might be worth investing in, right? And spending the ongoing cost of maintaining. That's a hard balance to strike because I think a lot of times we were talking about before, this grows organically. You don't think like, oh, this code is going to be used by everyone. And then it is. I guess that's a good problem to have. But, or you could think, oh man, so many people are going to want to use this code and spend so much time documenting it. And then, it never is.
Yeah, that's yeah. You want to do lazy evaluation here. Like you want your project to get uber popular and then to document it as an uber popular project.
But that's tough
afterwards.
to do too.
Yeah, I mean, well, I'll put it on your plate. Let's say you inherited some project that had like you inherited Firefox, the code base.
Oh dear.
And it has, you know, maybe it has some inline doc. Like, how would you document something like that? Like, what would be the best? It's tough.
But I
It's a
mean,
tough
like you were
question.
saying, like Firefox is a good example. So like lots of people, and I have no idea about specifics of Firefox, but lots of people use Firefox, but most people don't use it as like an SDK. So the kinds
That's a good
of
point.
the kinds of things like
Yeah.
what is their JavaScript engine called? I forgot now. But
Gecko or something, is that right? Oh no, Spider Monkey.
yeah,
Yeah, Spider Monkey.
Okay. So I'll take your word. Spider Monkey, like, he probably needs better documentation than like the font renderer.
Yeah, that makes
No,
sense.
I'm picking stuff up, but right, like trying to understand like as a whole, Firefox probably doesn't need equal documentation. So I guess it's the same thing like we were talking about in the files. It's recursive. Oh dear.
So yeah, maybe if I had to come up with a strategy here, I would say if you're writing something that starts to attract a broad base of developers, like let's say more than 500 developers or something like that, or you're building an SDK where the goal is to have thousands of developers, like that is the sole most important goal, then go this generator route and take the time and effort to do all the manual curation and stuff like that, so that you've pruned out all the meaningless stuff and you document everything for the stuff that matters.
Yeah.
But then for every other part of your system or for every other thing you work on, yeah, just skip the generator and do the comments, you know, kind of yourself in the function and all of that.
I will say actually of a lot of the ones I've used, Java docs are pretty good because I feel that if you use them just in the minimally intrusive way, they're pretty helpful. And even if you never generate the docs, like I don't think I've ever generated Java docs, the output. I don't know. I wouldn't even know how to do it, actually. So I'm pretty sure I've never done it before.
I've done Doxygen and Sphinx. We have and JS docs. But I've never done Java docs either. I've only seen them.
But I will say that I have read lots of Java doc comments in source code. And that for the most part, that when people go kind of sort of crazy overboard, I think they do strike a decent balance. Like you can use it as a sort of slightly more structured comment. And then it's just sort of this side benefit that it also happens that if you do that, you could get this generated documents.
Yeah, actually, we should explain that a little bit. So the way these generators actually work under the hood is, in the generator documentation, they're going to explain, specifically how you need to document, whether it's a function, a class, whether it's the top of the file, a module in the case is what it's called in Python, or a variable name, so on and so forth. It's going to tell you, look, if you want to document this parameter of this function, this is exactly what you need to write. It's usually some preamble text or something like that. And that's going to let the generator know the context of what you're about to say. And then you write your comment. And maybe it's based on a line break or based on 2 line breaks or something like that. That's how it knows to reach the end of that. And then what the generator does is it will recursively parse through all of your source code, pull out all of those relevant comments and the code that it pertains to. It's usually just based on the code that is immediately following the comment. And then it will generate, and it can generate a lot of things, HTML, it could generate a PDF. One of these generators could generate all of these different formats. And so you could literally just get a PDF with, all of this documentation and print it out and give it to somebody and say, here's the manual of my code. So in that sense, it's really cool. But as we talked about, it has to be done. It's the auto-generated stuff isn't, that elegant. You still have to do some hand-holding. I use Doxygen for my PhD code. So My PhD project was like relatively popular. I don't know. Let me look it up.
Oh dear.
Yeah, now it's probably.
Now I'm gonna
no
feel
one's
bad.
using it.
No, don't end this with me feeling bad.
Well, this is like years and years of work with no pay, so you should not feel bad at all about this. But yeah, and I used Oxygen for that, and I felt like it was pretty reasonable. I want to bet probably nobody looked at it, but it kind of, one thing it does is it kind of enforces you, puts some pressure on you to document everything, because it looks weird when you generate this document and half the stuff's empty.
While you're looking that up, I mean, I think documentation in general is one of those things that everybody feels we could do better at. And I don't know that anyone. I know I don't think there's exactly a clear best balance of it. So be practical, but do write documents. Don't be the guy or gal on the team that says, "Nah, documents, my code is amazing. It doesn't need documentation."
Yeah, another thing is, a lot of people don't. What's the word for this? Okay. A lot of people don't, if you're running a bunch of shell commands, you might not put that into a file, and you should do that. So in other words, the biggest documentation faux pas I've noticed is actually, and maybe it's just the nature of the particular, type of programming I do, but the biggest mistake I see is not people not documenting the functions and things like that, but it's somebody has like this, oh, I run this and I run this command, I run this command. It ends up being like literally like could be 10 commands, and they just type them all in every time. Don't do that. like even if it's just one command, make a bash script, document the bash script, and put it in the repository. So you'll notice if you go to the Eternal Terminal repo, I have a bunch of bash scripts that are just one-liners, and they're not even that complicated, but it's just so easy to forget these one-line bash scripts,
Indeed.
So yeah, I think just when it comes to shell, documenting shell, and the flow is actually really important. So,
all right, man.
But yeah, it's, I guess to conclude it, it's a living thing. Don't expect to have some silver bullet. Patrick and I, between the two of us, we've been in software. I mean, what are you gonna, combined a lot of years. Too many years. Actually, the other day, anyway, I'll go on a tangent on this. But yeah, we've been doing this for a long time, embarrassingly long time. And we don't really have a silver bullet here. In general, the like with anything like this, it's just to stay on top of it. So personally, the stuff I'm doing now at work, I've definitely gone loose on the documentation. It's something that wasn't very popular, and now it's becoming more popular. And so now it's time to say, okay, I'm going to take a week and I'm going to just really clean up the documentation. And what that will do is it will actually force me to clean the code as well. Like organize the code into different, organize the files and things like that. And so just treat it like that, instead of trying to find some perfect plan in advance, just look backwards instead of forwards, see how things are going, and then kind of keep adapting. All right. Thank you so much for supporting the show through Patreon, Audible, also through your emails. This actually was a recommendation, but it was a recommendation from over a year ago. And I was just going through, old emails and specifically looking for show topics. I saw this one. I thought, oh, this is a great topic. It could really appeal to anybody. And so I honestly didn't keep track of who told me what, but whoever suggested this, thank you. And for people who send us emails, reply to us on Twitter, Facebook, so on and so forth, thank you so much for your feedback. And financially, obviously, is great. It keeps the servers running, keeps the lights running, lets us buy microphones and things like that, so we can kind of reach out to more people. So thanks a lot, and we'll see you next month.
The intro music is Axo by Binar Pilot. Programming Throwdown is distributed under a Creative Commons Attribution Share-alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.